Here's an example for you to try. In a moment, I'm going to ask you to pause the video and work out your answers and then unpause and check your work. So here is a polynomial position function. I would like you to first determine the units on the coefficients, 3, minus 4, and minus 17. What must those units be? Then find the velocity as a function of time, then find the acceleration as a function of time. Go ahead and pause the video now. Did you pause it? Pause it. Work it out. Ready? Okay, here's the answers. First of all, our units here, on the 3, there's a meters per second cubed, so that when we multiply by seconds cubed here, it cancels with seconds cubed there and gives us meters. Likewise, on the 4, it should be 4 meters per second squared. So seconds squared cancels with seconds squared, leaving meters, and that should be meters. So meters, meters, and meters all match. Then, taking our derivatives, the derivative of 3t cubed should be 9t squared. The negative 4t squared becomes negative 8t, and the constant term, negative 17, disappears. When you do this sort of thing in written work, you know you always need to state your equations before you use them. This is the equation that you should state. And likewise, when you find the acceleration, this is the equation that you should state. So on your page, before you write down the derivative that you have, before you write down the sort of equation that you find by applying the derivative rules, you would write this first. V equals dx dt, that's stating your equation. Acceleration equals dv dt, that is stating your equation. Include that on the page first before you write this. Okay, and then taking the derivative for a second time, 9t squared becomes 18t, negative 8t becomes negative 8, and there we have it. Okay, next task. I would like you to find the following. Find the position at t equals 1 second and at t equals 5 seconds, the instantaneous velocity at 1 second and at 5 seconds, and the instantaneous acceleration at 1 second and at 5 seconds. Then you may or may not need to use that information to find the average velocity over the time interval from 1 to 5 seconds and the average acceleration over the time interval from 1 to 5 seconds. Pause the video again and work those out, please. Chance to test your understanding of average velocity and average acceleration functions. Did you do it? Okay, here's the answers. Just evaluate your functions up here. Put in 1 second for t, 5 seconds for t, 1 second here, 5 seconds here, 1 second here, 5 seconds here. Evaluate those functions to get these positions, velocities, and accelerations. And then the proper way to get the average velocity and the average acceleration is to use these integral over interval formulas. The most common mistake to make here for average velocity would be to do something like this. If you just took the velocity at 1 second and 5 seconds and found their mean, that is wrong. That only works if velocity is a linear function. And as we see here, velocity in this case is not a linear function, it's a quadratic function. So this doesn't work. If you did that, go back to the drawing board, try again using these formulas. So for average velocity, we need delta x. So x at 5 seconds minus x at 1 second over the delta t, 5 seconds minus 1 second. That comes out to be this. And then for average acceleration, delta v over delta t, find your v at 5 seconds minus the v at 1 second over 5 seconds minus 1 second. Note here, in order to find average velocity, did you need to first find this velocity function? The answer apparently is no. To find average velocity, you just need to evaluate the position function. So starting from way back here, you could have found the average velocity using this over that time interval without taking any derivatives. Last thing I'll point out, to find the average acceleration, did you actually need the acceleration function? No, you didn't use it. You needed the velocity function evaluated twice. So to find average acceleration, you can just take the derivative of this once to get the velocity function, evaluate that twice at 5 seconds and 1 second, and that's enough information to find the average acceleration over that time interval.